Today we're going to be going over how to put together a purification table. So on the left here is a partially completed table. And so these are useful when you're trying to describe your process and how good or maybe not so good the results are. And so we have several columns here that I'm going to describe. And this table was derived from this paper, at least the date I'm going to use today, from Preparing a Purification Summary Table, which was in Methods in Enzymology. So you can note where to look that up. It's got some more interesting information if you want to dig deeper. So this first column, these are the steps of your purification. So it includes your crude lysate, which would be, for instance, if you're using E. coli, right after the cell lysis. And then you would then spin down and filter to create a crude extract. And then following that, you would do ammonium sulfate precipitation. Then your protein would be his tagged, so you'd need to do an IMAC or metal affinity chromatography. And then finally you would do hydrophobic interactions chromatography to get the sample homogeneous. And so that's why on the far left we have, under purity, we have 100% purity. And so that's going to be important as we're doing the rest of the math here. And so your other columns are going to include your protein. So this would be milligrams of protein. And as you can see, it decreases as you purify your protein. And so that makes sense. You're going to have some yield loss. And so that's reflected here. So your final sample is going to be basically 3.6 milligrams. And then your activity, so this could be, for instance, an enzyme assay. So a lot of times when we're purifying proteins, they have an enzymatic activity that we can use to track the progress of the purification, and those typically are presented as activity units. So that could be a unit would be essentially how much product, typically in micromoles, gets converted. So let's write down this here. So that would be micromoles converted per minute. Okay. So that's activity. And in the lab that I teach, we're actually using what are called relative fluorescence units, or RFUs, because we're purifying green fluorescent protein, which has no enzymatic activity, but you can see it by the fluorescence in our fluorometer. And so the RFUs could be kind of a surrogate for activity, because if you have more of that particular protein, you're going to get a higher fluorescence. And so that could be your activity. So we've got some numbers here in the protein and activity columns. Now we want to see, well, what is our specific activity? So that's essentially the units, which we've indicated as activity, per milligram of protein. And so what we're going to do here is we're just going to see if I can get rid of this pen now. I think I just hit escape. And so here, this is going to be in, well, let's start here. Our protein is going to be in milligrams. Put some parentheses around that. And then the activity is we're going to say units, or RFU. And so the specific activity is basically the units per milligram of protein. Let me adjust that a little bit. Okay. Then, so those are the first columns. And then finally we have the yield. And so the yield is essentially how much of that activity did we lose throughout the purification. And so that that can be represented by the yield percentage. And so I'll show you how to calculate that in a minute. But first of all, we're going to calculate the specific activity. So now I have the specific activity filled out. So as you can see, our first value is calculated by taking the activity units, which is 120, and then dividing that by the protein, which is 1200. And so that gives us 0.1 units per milligram. And as you can see, I went ahead and filled out all of the other lines. And what you'll notice is as the protein becomes more pure, the specific activity increases. And so we'll be using this when we get to our purity measurement. Next up, we have our yield measurement. And so the yield is essentially how much of our activity did we hang on to during our purification. And so the yield is based on the initial measurement, which was 120 units. And so for the first step, it's 100% because what we're going to do is divide by 120 divided by the total, and that gives us 1, and multiplying times 100, we get 100% yield. Now, if we want to take this next value, we're going to take 110 and divide that by 120, which is the total, and then multiply this times 100, and that gives us 91.66, and so that would just round it up to 92%. So then I completed the rest of the steps, and then as you can see, as we purify the protein, the yield percentage is decreasing because we're basically losing activity. At each step we're selecting fractions, and so not all those fractions that we select encompass all the activity, and so we lose a little bit each time. All right, and now finally we have our purity measurement. So I went ahead and completed that table, and so the purity measurement is reflected by the specific activity. And so the way we calculate that is we're going to take our specific activity at the beginning or whichever step, and then divide that by the final specific activity, and then that's going to give us a number, and then we multiply that times 100, then that gives us the total purity. And so this is 0.8% pure, and then by the end, it's 100%.